In this section, we'll briefly talk about solution concentrations. Obviously, this is needed for solution stoichiometry problems. Basically, a concentration provides a ratio of the amount of solute to the amount of solution. The most common one that we'll use in the lab, and that's used throughout chemistry, is molarity. And we should have had experience with this already. So molarity is defined as the moles of solute divided by the liters of solution. So for instance, if we needed to calculate the molarity of a solution that's created by dissolving 1 mole of sodium chloride in enough water to make 0.5 liters of solution, our molarity, according to the formula up there, moles of solute, 1.00 moles of sodium chloride over 0.5 liters of solution would give us a molarity of 2.0, maybe one significant figure, 2.0 molar. Preparing solutions is something that we'll have to do later on in the year. It's something obviously that I have to do for all of your labs. But the steps we go through for making a solution: first, we need to determine the amount of solute required. So we would do that usually using some kind of a mathematical expression. So if we knew the molarity we wanted, we could figure out the number of grams that we would need, or perhaps the volume if we were just diluting a solution. Then we would need to use the appropriate instrument to measure out the solute. So obviously if it's a solid, we'd be using a balance. And if it were a liquid that we were diluting, we would use a volumetric pipette to get the maximum precision in our measurement. If it were a solid, we would want to make sure that we took that solid and dissolved it into some water in a beaker first. You always want to make sure that the solid will dissolve before you put it into your volumetric flask over here on the lower right. Once you get your solid to dissolve, then you can add that mixture into your volumetric flask, and your final step would be to use the distilled water to fill the volumetric flask up to the calibration mark. If you were doing a liquid and just diluting it, you would add directly to the volumetric flask and then add distilled water to the calibration mark. When you're diluting a solution, it's a pretty simple calculation that we would use here. The idea when you dilute something, you're adding water to it, so it doesn't change the number of moles. So if we take our molarity equation and rearrange it to solve for the moles, we get moles of solute equals molarity times volume. If the moles of solute is the same before and after, condition 1 and condition 2, we get the formula M1V1 equals M2V2. So again, a brief example here. We have 10 milliliters of a 2.0 molar solution is diluted to 100 milliliters, and we want to know the new molarity. So the new molarity we would call M2 would be equal to M1V1 over V2. We plug in the initial molarity, the volume of that solution that we used, and the final volume that it's diluted to. And we would see that the new molarity would be 0.20 molar. So after practicing a few problems with this, we'll be just peachy keen and ready to start doing some stoichiometry problems with solutions, in particular titration problems.